In this lesson we're going to prove that 3 points lie in the same straight line. That's to say that they're collinear. So how can we do that? How can we prove that these 3 points lie in the same straight line? Well, you could work out the gradient from here to here, and you could work out the gradient from here to here. And we could say because the gradients are the same, these lie in the same straight line. But that's not all we have to do. For example, if I said that we had a point here, and I said A was here, and B was here, and C was here, then that gradient would be the same as this gradient, but they wouldn't all lie in the same straight line. So I need more than just to talk about the gradients. The extra part I need to do is to say that they share a common point. So in this example, I'd work out the gradient of this and the gradient of that, and they both share B as a common point, and that would mean they would all lie in the same straight line. So let's look at an example of this. Prove these 3 points are collinear. So do a wee quick sketch. It's best to do that, a wee quick sketch like this, just a simple one. Try and put the points in order. So -6 comes first. Look at the x coordinates. That's the easiest way to see in order. So that comes first, then 0, then 8. Luckily these ones are in order, but if they're not, put them in order. Next thing, work out the gradient of PQ, and then work out the gradient of QR. So let's look at doing that. Gradient of PQ equals 2 subtract -1 over 0 subtract -6. So that becomes 2 plus 1 and 0 plus 6. So that goes down to a half. Work out the gradient of QR. So delta y over delta x again. 6 take away 2 over 8 take away 0. So that comes to 4 over 8, which is a half. So we've worked out the gradients are the same. Make a statement, since the gradients are equal and Q is a common point, points P, Q and R are collinear. You must put this in or you lose a mark. Final example, we have 3 values here. Again, draw a wee quick sketch. You can see that that would be first on the number line, -12. Then you would have -4 for F, and then you would have 0. So sketch out like that, E, F and D. So I would work out the gradient of ED, which is delta y over delta x. So -2 over here, subtract -8, and then over -4 subtract -12. That comes to -2 plus 8, which is 6, and -4 plus 12, which is 8, and that simplifies to 3/4. Then work out DF. So that would be -2 take away 1, or 1 take away -2, and then 0 take away -4. So that would come to 3 over 4, which is the same. So in this example, what I've done is I've worked out ED and then DF. So E to D and DF. So the common point this time is D, which is that point there. So since the gradient of ED equals the gradient of DF, and D is the common point because we used ED and FD, then ED and F are collinear. We could have done the gradient of EF and FD and used F as a common point. It's entirely up to you which one you do.